Hi everyone. Our group will present the question 2 from assignment 1, MTH4602. Before that, we will introduce ourselves first. So my name is Nurfahimah NABIHAH binti Muhammad Sofyan and my matrix number is 202970.
Hi everyone, my name is Wahida NAJIHA binti Manizam and my matric number is 202390.
Hello everyone, my name is Pavitra Gopalakrishnan and my matrix number is 202246.
So hi everyone, my name is AYUNI binti Abu Jamil and my matrix number is 203854. So without further ado, we will share our answer now. Okay, so this is our question for the question number 2. So the question is, if the control equation for a certain system are, the equation is s1 dot equal to s1 minus 3x2 plus u. The second equation is x2 dot equal to 2x1 minus 4x2 minus e power of negative t multiplied with u. So calculate the transitions matrix and hence calculate the response xt to the control ut equal to e power of negative t if x1 equal to x2 equal to 1 at t equal to 0. So we will start to answer the questions. We transfer the question above to this form of matrix, which is x1 dot with x2 dot equal to 1 minus 3, 2 minus 4, multiply with x1, x2 plus 1 negative e power of negative t. So consider it as an equation xt equal to ax plus bu, which we will get equation for a and b, which a is 1 negative 3, 2 negative 4, and b is 1 negative e power of negative e power of negative t. So now xt equal to, we will use the general formula, which is we will find the inverse of lambda identity minus A. Okay, so the lambda identity minus A, we will get lambda 0, 0 lambda minus 1, negative 3, 2, negative 4. So we will get lambda minus 1, 3, negative 2, lambda plus 4. So we will find the inverse of the matrix, which we will get lambda. So next we will find the answer, which lambda minus 1 multiplied with lambda plus 4 equals minus negative 2 multiplied with 3. Then we will get the final answer, which lambda square plus 3 lambda plus 2. So we will find the inverse of this equations. So we will get lambda plus 4 over lambda square plus 3 lambda plus 2 minus 3 over lambda 2 plus 3 lambda plus 2 to lambda squared plus 3 lambda plus 2 lambda minus 1 over lambda squared plus 3 lambda plus 2. So next, from the inverse equation from before, we will use inverse Laplace transform. So first we will find for the lambda plus 4 over lambda squared plus 3 lambda plus 2. We will use to find the value of A and B, and we will use the lambda that we use in the partial fraction. We will use lambda equal to negative 1 and also lambda equal to negative 2. By using the lambda, we will get the answer for A and B, which is 3 for A and negative 2 for B. Yes, okay. Thank you, Pavitra. So we will get the final answer, which we simplify it as e power of negative 2t multiplied with 3 e power of t minus 2. Okay, next one, we will find the different equations, which is we will use negative 3 over lambda square plus 3 lambda plus 2. We will use the same
Partial fraction.
yes, using same method, which is partial fractions. So for this we will use lambda equal to negative 1 and lambda equal to negative 2, and we will get a equal to 3 and b also equal to 3. So the final answer for the equations is negative 3 e power of negative 2t multiplied with e power of t minus 1. So next, this one we will find for 2 over lambda square plus 3 lambda plus 2. And we use the same method also, which is partial fraction. And we use lambda equal to negative 1 and also lambda equal to negative 2. And we will get the answer for a equal to 2 and b equal to negative 2. So the final answer for the equation is 2 multiplied with e power of negative 2 multiplied with e power of t minus 1. So the last one, we will find for this lambda negative 1 over lambda square plus 3 lambda plus 2. And we use also the same method, which is partial fraction. We use lambda equal to negative 1 and lambda equal to negative 2. And we will get a equal to negative 2 and b equal to 3. So the final answer is negative e power of negative 2t multiplied with 2 power of e power of t minus 3. So from the 4 equation, we will form a new metric form. So we will get the state transition metric, which is as t equal to e power of negative 2t e multiplied with 3 e power of t negative 2, negative 3 e power of negative 2t multiplied with e power of t minus 1, 2 e power of negative 2t multiplied with e t power of t minus 1, and the last one minus e power of negative 2t multiplied with 2 e power of t negative 3. So this is our final answer for this question. That's all from us. Thank you.
Thank you.